This video is about exponential functions, and an exponential function is where you have some number that's the base and it's taken to the x power. And we don't want to let our base be 1, and it also needs to be positive. And that's because if we, it's not like there's anything wrong with our base being 1. It's just that that is always going to be 1. And so that actually ends up just being a constant function. And if we graphed it, it would be a horizontal line, and it just won't end up having an inverse. So it doesn't share the characteristics of all the other exponential functions. So we just exclude that one. And then also, if we let our base be negative, there just ends up being kind of strange situations when, I'm going to kind of make this a tiny bit bigger. If we tried to graph this, if we had, let's say, our x is 1/5, we could take the 5th root of -2, and that's about -1.15. But if we tried to take the 4th root, that would be the 4th power, or the 4th root of -2, which is undefined. And a third, you can take the cube root. Let's see, cube root of -2, that's about -1.6. But if you took it to the half root, square root of -2 is undefined. If you took it to the 0 power, that's 1 if you square it. So what ends up happening is there's just all these funny little holes where it's undefined, and so it doesn't share characteristics of all of the other exponentials if you had a positive non-1 number base. Okay, so that's why we have those conditions, because it just allows us, if a is positive, it leads us to a function that is connected without any holes. And then if we have a where it's not equal to 1, then it ends up being, we're able to have an inverse. Okay, so if we just set those conditions, then we have some characteristics that all exponential functions share. And I'm going to just give an example with if our base was +2. Okay, so if I went to graph this, and I could have x be anything I wanted, let's see, -1, 0, we could even have a half, and 1 and 2. Okay, so if I had 2 to the -2 power, what that does is it takes my base and it takes it the reciprocal of the base to the positive power. So we would have a 4th. If we had 2 to the -1, it would be the reciprocal of the base to the +1 power, so that'd be a half. And 2 to the 0 is 1. And then if we took it to the 1/2, that would be the square root of 2, which is about 1.4. 2 to the 1, that's 2. 2 squared, that's 4. Okay, so what ends up happening is these grow very slowly, and then they really start shooting up, because if I had 3, it would be 2 cubed. If I had 4, it would be 16. So they start growing quite dramatically after that initial slow growth in the very, very beginning. And then they're going to share this y-intercept. So our domain here will be from -infinity to infinity. It does not have a vertical intercept. And let's see, my range goes from, it can't get to 0, and it goes up towards infinity. The horizontal asymptote, is y equals 0. There's no cross or touch points, and the y-intercept is that 0, 1, and then there's no x-intercepts. So that's your parent graph. Now if I had g of x equals 1/2 to the x, notice that that's the same thing as if I had 2 to the negative x. Okay, so let's look and see what happens on those. Those are the same exact function, right? Because my negative would take the reciprocal, so it would make it 1/2 to the positive x power. All right, so let's investigate that function a little bit more. Okay, so I'm going to do my inputs. And let's see, if I had 1/2 to the negative 2, it would be the reciprocal to the positive power, so that would be 4. I'll do this one in green. So at negative 2, we'd be up at 4. At negative 1, we'd have 1/2 to the negative 1, so the reciprocal 2/1 to the positive power. At 0, we still have the same y-intercept of 0, 1, and then we just have a 1/2 and a 1/4. 1/2 squared is 1/4. So then it's going to come down, and we'd be at an 1/8, a 16th. Okay, so in this case, these are decreasing functions with that same y-intercept, same horizontal asymptote. So it still shares these same properties. It's just depending whether you have a base that is smaller than 1, a fraction smaller than 1, or if you have a base that is larger than 1. All right, so now let's look and see what happens when we start doing some transformations. We just graphed that, but then if you took it to the 1/2, okay, so we just talked about how these two functions, let's see, this is the same thing as 1/2 to the positive x. Okay, so I'll just copy this down from the page before. Let's see, our range was from 0 to infinity. Our horizontal axis was 0, or y equals 0. Our y-intercept is 0, 1, and it does not have an x-intercept. Okay, and then we had the same characteristics for this one. I'm just copying this from the page before. Horizontal asymptote, that was y equals 0. Oops, sorry. Erase that. Okay. Y equals 0. Same y-intercept and no x-intercept. Okay, now let's look what happens if we have the opposite of 2 to the x. So I'm going to do my classic, I'll do the parent graph here. I'm going to do this one. Okay, so then we have at 1, we're at 2, output of 2. When the input x is 2, that means we're taking 2 and squaring it, so we'd be up at 4, and then up at 8, at a 1/2, a 1/4. So there's my parent graph. Y equals 2 to the x. Now, if I go and take the opposite of that, that is taking whatever input I had and just making it negative at the, so here I had an output of +1. Now I'm going to have an output of -1. Here I had an output of 2. It's just making it negative. So it's just reflecting it across the x-axis. All right, and if we make a quick little XY chart, we can just see that all that negative is doing is just making our final answer negative. Okay, so that's the reflection across the the x-axis there. All right, let's look at this next one. When we are taking and subtracting 2 at the end here, what that's doing is just going to do a vertical shift. It's going to slide everything down. Okay, so my original output of 1 here, it would just slide down. This one had an original output of 2, it would slide down to 0. This one was at 4, so we'd slide down. This one was at 8, so we'd slide down. So it's the same graph, but now we have a horizontal asymptote here at -2. Let's see, horizontal, this one is at y equals -2. And my y-intercept slid down as well, so usually my output was 1, but now I'm at -1. Let's see, I do have an x-intercept now. So I'm at (1, 0). And my range goes now from -2 to infinity, and my domain is the same. Okay, so there's that one. And that's just a vertical shift down. I didn't write this one down. This was my reflection across the x-intercept, or the x-axis, so we had same domain. But now my range goes from -infinity to infinity, and my horizontal asymptote is still y equals 0. And then my y-intercept is now 0, -1. And I have no x-intercepts. Okay, so we have horizontal, we have reflection, then we have a vertical shift down. Okay, let's look at this next one. This is going to end up being a horizontal shift. So I'll show you the graph and then we'll kind of look at why. All right, so when we're adding 1 in the exponent, it's going to just shift our graph to the left, 1. So each of these points is just scooting over 1 unit. Okay, so we have a horizontal shift 1 to the left, 1 unit. Okay, so let's think about kind of why that might be and what's actually happening here. So if you have 2 to the x plus 1, that's what happens when you're adding exponents. And that would be the case if you're multiplying 2 to the x times another 2 to the 1. So what's happening here is that we're taking that original output of 1/4 and we're multiplying it times 2. So we end up with what used to be here at a fourth. A fourth is it's now at a half. So it's actually stretching it, but what ends up happening is we're just kind of shifting these because we used to have an output of a half for our output when our x was -1, but now that's shifted and our output now is happening back 1 unit when our input is at -2. Okay, so same thing here. If we had originally that output of a half, now that's happening. Now it gives us an output of 1, and that usually happened 1, over here. But now that we're getting that output of 1 a little bit earlier. Okay, so that's kind of why. So now let's kind of think about, well, what would happen if we subtracted 2? How does that affect our graph? If we add 3, things like that, okay? So let's think about that next. And then I just want to also make sure, because I hadn't written down this one. And remember, that's the reflection across the y-axis. Okay, so there's our transformations of exponential functions. So let's do a couple more examples. Okay, so here we're going to look at the parent graph and then the transformations in order. And we're going to graph the parent function and the transformations. And then we'll label the asymptotes for the last transformation. Okay, so our original function here would be y equals 3 to the x. And our y-intercept's the same, but now if we have input x as 1, we'd be up at 3. X of 2, we'd be squaring that 3. Here we'd be at a third, a ninth. So the bigger the base, the quicker the rise, the steeper that rise is. Okay, so let's figure out what we're going to do first. Let's deal with this minus 2. That's going to be a horizontal shift to the right, 2 units. Okay, so input of 1, that's when we'd have a third, and then our y-intercept there would be at 1/9. All right, and then our next one is where we're going to deal with our final negative here, which is going to be a reflection across the x-axis. All right, so those are two. This one would be the final function, our two transformations that happened. And we can kind of go in and actually sort of explore what is going on and why is that the case. So if we were at negative 1, 0, 1, 2, 3, and we have y equals the opposite of 3 to the x minus 2. Okay, so this means I would have the opposite of 3 to the negative 1 minus 2. So usually before I did my subtracting 2 more, I would have just 3 to the negative 1, so it would be a third. But now it's 3 to the negative 3. And then we have to take the opposite of all of that. So it would be the opposite of 1/3 cubed. So it would be negative 1/27. And now if we have to the 0, it would have 3. It would usually just be an output of 1. But now it's not just 0, it's minus 2. So we would have the opposite of 3 to the negative 2, so it would make it 1/3 to the positive 2. So we'd have negative 1/9 for our y-intercept. And now we'd have the opposite of 3 to the 1, but it's not, right? We're shifting this all over. We'd have the opposite of, this would be 3 to the negative 1. So this is where we get an output of a third, but then we have to make it negative. Oh, sorry, I wrote that as a 2, but that's a 9th. And then we have the opposite of, usually that would be an output of 9, but we're subtracting 2. So we'd have the opposite of 3 to the 0, which is negative 1. Right? Because we have the opposite, anything to the 0 is 1. Okay, and now we have the opposite of 3 cubed. That would have been usually 27, but it's not because we're subtracting 2. So this is actually the opposite of 3 to the 1. So it's negative 3. Okay, let's try another one. So I encourage you to pause the video and see if you can come up with this. Think of these. The first one we're doing is we're dealing with that negative x, okay? And then the next one that we're going to do is that minus 4. Okay, and then the second one is we'll take that and then subtract 4 from the output. All right, so like I said, just see if you can come up with what those will look like. Okay, so our first one is a reflection about the y-axis. And then the next one is going to slide down. Four units. All right, so we're just sliding down and we've got our horizontal asymptote now at y equals negative 4. And what is our y-intercept? Is at 0, -3. And let me just make sure that I have here, this is the same horizontal asymptote at y = 0.